Hello, everyone. In our last class, we discussed the concept of work in physics. Today, we're going to talk about something very closely related, and that is energy. You'll soon see that work and energy are almost like two sides of the very same coin.
So, let's begin with a question to get us thinking. We know that for work to happen, a force has to move an object. But what is it that an object must have to be able to do this work in the first place? What gives it this capability? That's exactly what we are going to find out today.
So here's a little roadmap of our lesson. We'll start by building a bridge from work to energy. Then, we'll define what energy really is. After that, we'll learn how we measure it, look at all its different forms, and finally, we'll quickly summarize everything we've learned.
Okay, let's get started with our first section. We are going to connect what we already know about work with this new idea of energy.
Let's just have a quick recap. I want you to remember this very clearly. In science, for us to say that work has been done, two conditions are absolutely necessary. First, a force must be applied to an object, and second, that object must move, it must be displaced. If either of these is missing, no work is done.
Right. This brings us to the heart of our topic today. If work needs a force that causes movement, then what is this mysterious capability that an object has which allows it to apply that force? Well, this capability has a very simple name. It's called energy.
And here it is. This is probably the most important sentence for today's class. Energy is the capacity to do work. It's such a simple definition, but it's very powerful. It means if an object has energy, it has the ability or the potential to do work.
And you know what? You see this idea in action every single day. Just think about it. To play, to run, even for all the basic things your body is doing right now to keep you alive. All of these things need energy. And where do we humans get this energy from? Well, we get it from the food that we eat.
And it's not just us, not just living things. Machines need energy too. A car, for example, can't just move by itself. It needs energy. The engine burns fuel, like petrol or diesel, to get energy, and it uses that energy to do the work of moving the car. Let's look at a couple of fantastic examples. Imagine a cricket ball moving very fast. It has energy, right? And because of that energy, it can do the work of knocking the wickets down. Or think about a hammer. When you lift a hammer high up, it has energy. And when you swing it down, it does the work of pushing a nail into the wood. You see, both the cricket ball and the hammer show us the same thing. They prove our main idea for today. Energy is the capacity to do work. So how does this actually happen? How does an object with energy do the work? Well, it's a transfer. The object that has energy, it applies a force on another object. When this happens, the first object loses a little bit of its energy. And where does that energy go? It gets transferred to the second object. The second object gains that energy, and that's what makes it move. That's how work is done.
Okay, so if energy is a physical quantity, if it's the capacity to do work, then it makes sense that we should be able to measure it. Just like we measure length in meters, we need a special unit to say exactly how much energy something has.
Now, this is a very important point. Since energy is the capacity to do work, these two ideas are connected very deeply. They are so closely linked that, guess what? The unit we use to measure both work and energy is exactly the same. And that special unit is called the joule. We write it with a capital J. The relationship is simple. To do 1 joule of work, you need 1 joule of energy. It's a perfect one-to-one connection. It can't get simpler than that.
Now, sometimes we talk about very large amounts of energy. So just like how we use kilogram instead of saying 1,000 grams, we use something called a kilojoule for energy. A kilojoule, or kJ, is simply 1,000 joules. It's just an easier way to write big numbers.
All right, now for a really fascinating part of our lesson. You see, energy isn't just one thing. It's all around us, and it comes in many different forms. Let's explore some of them.
So energy can appear as mechanical energy, heat energy, chemical energy, electrical energy, or even light energy. I'm sure you have heard all these terms before. Today, we'll understand what they mean. Let's start with the first one, mechanical energy. This is the energy an object has because of its movement, or because of its position. And mechanical energy itself is made of two different types. One is called kinetic energy, and the other is potential energy. Let me ask you something. Think about a speeding car, the wind that blows, or a running athlete. What do all of them have in common? Well, they are all moving. The energy that an object has simply because it is in motion is called kinetic energy.
Okay, but what about this? If you stretch a rubber band, it's not moving, is it? But if you let it go, it can fly across the room. It can definitely do work. Or think of a wind-up toy car. It's just sitting there. But if you release it, it starts moving. So where is the energy? It must be stored inside them, right? This stored energy is what we call potential energy.
And of course, besides mechanical energy, we see other forms everywhere. The heat we feel from a fire, the chemical energy stored in our food or in a battery, the electrical energy that powers our homes, and the light energy coming from the sun. These are all different forms of energy.
Phew, we have covered a lot today, haven't we? So before we finish, let's just take a moment to quickly go over the most important points we learned.
So what are the main things to remember? First, the definition. Energy is the capacity to do work. Second, we measure energy in joules. Third, energy comes in many different forms. And finally, and this is very important, an object can have stored energy, potential energy, even when it is completely still.
And that leads me to one last question for you to think about. We know a moving car has kinetic energy, but in physics, we like to be precise. We like to calculate things. So is there a way to calculate exactly how many joules of energy that moving car has? Well, the answer is yes, and that is exactly what we are going to learn in our next lesson.